Oh, hello. Mr. Phil here, and I'm going to expand upon the fraction ideas we've been talking about in this series so far today with subtraction of fractions and how to do this um, effectively. So, the first thing that you need to understand is addition and subtraction of fractions, you're going to pretty much approach in the same way. You absolutely need to have a common denominator before you do anything. And like in the addition of fractions with mixed numbers video that I made, instead of changing your mixed numbers into improper fractions right from the beginning, I'm going to show you a little method that I call borrowing. Yes, borrowing, just like you did with double digit and triple digit subtraction. Um, but you can do that with fractions also. So here's how you do it. The first step, of course, is finding the common denominator. And for 3 and 5 down here, the common denominator is 15. So I'm going to start to set up my problem like so, just so I know what to do. And make sure I don't forget that my common denominator is 15. So to get from 3 to 15, I multiplied by 5. So I've got to multiply the top by 5 as well. So 1 times 5 is 5. To get from 5 to 15, I multiplied by 3. So I have to multiply the top or numerator by 3 as well. So 4 times 3 is 12. Now we want to subtract, but we cannot because if you notice this fraction here, 5/15 is smaller than 12/15. So what do you do in that case? Well, this is where the borrowing step comes in. And I'm just going to highlight that fraction to know that that's the only fraction we're touching. When we subtract and we have to do this borrowing step, we are never going to address the fraction to the right of the subtraction sign, only to the left. And the reason why that is because at this point, most students have not learned about negative numbers yet, so the bigger number is always going to be written on the left. Once you've learned about negative numbers, there's a slightly different approach. You just have to be aware of which number is bigger. Anyways, so what we're going to do here to borrow is two simple steps. You are going to take 1 away from the whole number, so that 1 is going to become a 0. So just for organization's sake, I'm going to write the 0. And then what you do is you take the numerator up here and add it to the denominator. What that's going to make is the new numerator. So it's going to be 20 over 15. Now in this case, I know a lot of you are saying, oh, well, you could have just taken 1, multiplied it by 15, and then added the 5. But that doesn't always work all the time because you don't always want to make it a complete improper fraction. We just want to make it big enough, this fraction big enough to be able to subtract from here, or subtract this fraction from it. So now that we've done that and taken 1 away from the whole number and then added the bottom to the numerator to make the new numerator over here, we can subtract. Now this 0 is inconsequential, so I'll cross it out. But the reason why I wrote it here is so you can see in the next problem why I did that. Anyways, now we can subtract 20 minus 12. That answer is 8 over 15. We cannot reduce it any further, so we are done with that problem. Boom. 8/15. Okay, so the next problem. I'm going to write that in red ink. How about let's do purple just to be a little bit fun, and I'll write it down here. So we're going to do the same thing, write the whole number, but we're going to change the common denominator, right? So here's the 2. For 9 and 6, of course, you can multiply them together at 54, but that is not the lowest multiple that 9 and 6 share. It's actually 18, so I'm going to change both denominators to 18. And then now I need to adjust the numerators to reflect this change. So I multiply 9 by 2 to get 18, so I must multiply the numerator by 2. Here I multiplied 6 by 3 to get 18, so I must multiply the numerator by 3. So now that we've changed the fractions to common denominators, we would normally try and subtract. But if you look at the fractions here, I cannot subtract 4 minus 15. I always check the fractions first, just in case I need to do the borrowing step. So this is where the taking 1 away from the numerator is, or not the numerator, the whole number is going to make a big difference. So here's the borrowing step. We take 1 away from 4, the whole number, and it becomes 3. And then, like I said before, I'm going to add the denominator of this fraction to the numerator to make the new numerator, the new top. And of course, the bottom stays the same. If you remember from the previous example, I said you never change the number to the right of the subtraction sign, so I'm just going to keep 2 and 15/18 as 2 and 15/18. So now that the fraction on the left is bigger than the fraction on the right, we can subtract. It's set up nicely for us. 3 minus 2 is 1. 22 minus 15 is 7. And then the denominator stays the same. We cannot reduce anymore. There's nothing left to do. So that's our final answer. And there you go. That is the borrowing method. You can use this for any type of subtraction with fractions. And just to kind of reiterate the point, if I go back and I show you the same idea with improper fractions, you can see here I changed 4 and 2/9 to 38 over 9, and then I changed 2 and 5/6 to 17 over 6. You can see how once I get common denominators, I've got to multiply 38 by 2 and then 17 by 3, subtract them. It'll most likely be an improper fraction, so I like this method a lot better. I think it's just a little bit more straightforward. It's something you can apply to every subtraction problem, and I think it's that consistency of using the same steps every time you approach a specific type of problem. I think that's what builds skill. That's what helps with your memory and also confidence, hopefully in the end. So there you have it. I think there are definitely more efficient ways of solving operations of fractions like addition and subtraction. So I hope you can put these ideas and thoughts into practice. Really get used to, especially when it comes to mixed numbers with addition and subtraction, learning to keep them as mixed numbers so you only have to manipulate the fraction part. Like I said in the instructional portion, of course, if you have smaller denominators, it's not really going to make that much of a difference or be that much more difficult if you change mixed numbers to improper fractions right away. But I would say because the fractions that you're going to deal with later on are probably going to be much more involved and larger in size and value, it's just a good skill to learn because it's faster, in my opinion. But of course, if one way works better for you and you've tried 2 or 3 different ways, stick with the one way that gets you the best results. That's what learning is all about. There's no set pattern that everyone has to follow. There are just ideas and ways that are more sensical and logical to certain people. So get out there and explore and try it. It's not fun, but it's necessary to be really good at math. So I hope you can take those ideas and tips and put them into practice. I wish you the best of luck, and as always, I am wishing you well. Bye.